Welcome to part 3 of my 6x6 tutorial. At this point, all of your centers should be properly positioned and oriented correctly so that red, black, and blue are in a clockwise direction. Opposite of red you should have orange, opposite of black you should have yellow, and opposite of blue you should have green. You might also have white stickers if you have the black cube. If your centers are not correct at this point, please rewatch steps 1 and 2 for instructions on how to fix them before proceeding. What we're going to do in this part is learn how to pair the edge pieces of the 6x6 cube. As I have said in the first video, there are 12 sets of edge groups composed of 4 pieces, with 2 inner edges and 2 outer edges. The way I'm going to teach how to pair the edges is to start from the inside and work your way out. We're going to first pair the inner edges, and then we're going to pair the outer edges to the inner edges. This beginner technique will utilize methods from solving the 4x4 and also the 5x5 cube edges. I'm going to explain the general concept, however I'm not going to go through pairing every edge with you. My 4x4 tutorial part 2 and 5x5 tutorial part 3 cover edge pairing in more detail and can be found on my channel playlist. Once you have paired the edge pieces, you'll then need to fix any edge parity, which I will also explain in this video. Alright, so what are the similarities between a 4x4 cube and a 6x6 cube? Well, they're both even layered cubes. This one has 4, this one has 6. The 4x4 has 12 sets of 2 edge pieces, or 24 edges total, while the 6x6 cube has 12 sets of 4 edge pieces, or 48 edges total. The number of the inner edges on the 6x6 cube, however, is the same as the amount of edges on the 4x4 cube. So there are 24 total inner edges. So what does that mean? Well, this means that you can pair the 6x6 inner edges the same exact way as you would the 4x4 cube's edges. So how would you go about solving the 4x4 cube edges? Well, you find 2 identical edges. This one has white and blue on it, and this one also has white and blue on it. You set them on opposite ends of the cube. This one's on the left, and this one's on the right. You'll also notice they have different colors on the front. So this one has blue on the front and white on the side, while this one has white on the front and blue on the side. And they are in opposite layers. This one's on the inside up, and this one's on the inside down. Once they're positioned like that, you can match them up by twisting the one on top over to the one on the bottom. You could also twist the one on the bottom over to that way, but for simplification I'm going to show it this way. So I would move this one over to that edge. Now you notice they're pair up. However, the centers have been misaligned. So what you do is you want to get this newly matched pair out of the way and replace it with any other unmatched pair so that we can realign the centers. So once we match it up, you lift it and replace it with an unmatched pair. Now you'll notice the centers are misaligned, so you have to bring that unmatched pair back down, and then you could realign the centers and you don't have to worry about breaking that newly matched pair up. So that's the beginner method, and what that does is it gives us one newly matched pair. Alright, so let's start pairing the inner edges of the 6x6 cube. What you want to do is you want to find 2 identical edge pieces, just like you do in the 4x4 cube. So here I have an inner black and white edge piece, and here's another inner black and white edge piece. So what you do is you set them up so that one's on the inside up layer, one's on the inside down layer, this one's on the left, this one's on the right, this one has blue on front and black on the side, while this one has black on front and blue on the side. Then you just do the same exact thing. You pair them up by twisting 3 layers now instead of 2. So we want to twist all 3 of these layers just like that. Once they're paired, you need to get them out of the way and replace them with an unmatched pair. So you lift it up, twist it out of the way with an unmatched pair in this position now. You bring it back down, and then you just realign the centers. So there we have 2 pieces which are now next to each other. Looking around the cube again, you want to find 2 again. So here I have an inner red and black piece. Here's another red and black piece. So if this one's here on the inside up layer, we can get this one here on the inside down layer. So you bring this one down, flip that over there, and then bring it up. Now you'll see this inner up layer piece is on the right and this one's on the left. So we just do the opposite. We bring it this way now. So you pair it up, and then you get it, lift it up, look on top, you want to replace it with an unmatched pair. And then you bring it back down. Then you could twist the centers back to realign them. So you want to keep on doing that over and over again until you have either two sets of pieces which are left. In that case, there should be two pairs left that you need to match up. That would indicate you have a parity error. Now the parity error on the 6x6 cube is going to be exactly the same as the parity error on the 4x4 cube, since we are now organizing the inner edge pieces of the 6x6 cube. So you want to keep on edge pairing until you find that you have a parity error. So here I have another edge piece. Here's orange and black. I usually like to choose the black ones because they're a little bit easier to spot. So we pair this piece up, which is actually already set up to be paired with this one. So you pair it up, get it up and out of the way, and bring down an unmatched pair, and then you realign the centers. Alright, so keep on doing that until you have two sets, or until you completely match all of the inner edge pieces. Alright, at this point you should have tried to match up as many inner edge pieces as possible. You're either going to be able to match up all 12 pairs, or you're going to have two pairs left, in which case you have a parity error. This is the same exact parity error that you see on the 4x4 cube. So, as you'll see, you really can't pair these up, because even if I tried to pair this up to that, there's no other unmatched pairs left, and you'd wind up breaking one of the already matched pairs that you have. So, to fix this, you want to get the identical pieces to be on the same layer. As you'll see, this orange-blue piece is on the top, and this is on the bottom here. So, to get them in the same layer, you just bring this down, flip that over there, and then bring this back. So now that they're in the same layer, they both have orange on the front face, and these both have green. So, what you want to do is perform this algorithm to fix this error. Turn all three down layers clockwise, turn the right face clockwise, turn the front face counterclockwise, turn the up face clockwise, turn the right face counterclockwise, turn the front face clockwise, and turn all three bottom layers counterclockwise. So as you'll notice, these two pairs have now been fixed, and you can move on to pairing the outer edge pieces of the 6x6 cube. Okay, so by matching all of the inner edge pieces on the 6x6 cube, what we have done is reduced the 6x6 cube edges to a 5x5 cube edges. As you'll see, if these two pieces are visualized as one piece, it's going to be the exact same thing as solving the 5x5 cube edges. So, if you want to solve the 5x5 cube edges, you get two identical edge pieces opposite ends of the cube, just like you do with the 4x4. Then you would bring this piece over to this middle edge piece. You want to get two unmatched edge pieces now in this position so that you can bring the centers back and realign them. So once it's matched, you bring it up, twist it so that an unmatched pair is here, and then bring it back down. Now, when you twist this back, you want to make sure that these two pieces do not have a matched up edge. If you do, you're going to break it up when you realign the centers. So these two pieces are not matched, as you'll see. So I bring it back, and now I have one newly matched edge pair. So it's the same exact thing on the 6x6 cube. So what you want to do is you want to get a middle edge pair across from a single outer edge piece. So here I have red on the front and black on the front here. You want to have the opposite orientation. Then you can match it up by twisting these two top layers. Now I have three matched up. So then I bring this up and out of the way and twist an unmatched pair here and bring it back down. So now when I twist this back, this blue-white edge piece doesn't belong with these two anyway, so it doesn't matter. So, you want to keep on doing that. Looking around the cube, you want to find two pieces which you can match up. I'm going to consider this one piece. So, if I want to match up this orange-black piece to these two, I do the same thing. As you'll see, it's already set up properly, so all I have to do is twist it, lift it up, out of the way so that I have an unmatched pair in its place, and then bring that back down to realign the centers. So you just want to keep on doing that over and over again. Here I have an outer blue-white piece, blue-yellow, and here is the inner edge pair. So bring it down, over. Now they're opposite each other, so I pair it, get it up, out of the way, and bring it down. Realign the centers. Same thing, now I have this other outer blue-yellow piece, and I can match it with these three. Get them opposite, pair it up, lift it up, twist it so that an unmatched pair is here, and bring it back down. Realign the centers. So you want to do that over and over until you have two sets of four edges which have parity errors, or you might have been able to solve all of the edges. Alright, there are three main types of last edge group cases that I'd like to go over. For solving the last edge groups of the 6x6 cube, you can again visualize this inner edge group as one piece on the 5x5. So this parity error in which you see this one piece is flipped, this is the exact same case that you see on the 6x6 cube. So to correct this, you want to hold this last edge group on the top layer all the way in front as it is here. Then you're going to perform the following algorithm. Both right faces twice, the back face twice, the up face twice, both left faces clockwise, the up face twice, both right faces counterclockwise, the up face twice, both right faces clockwise, the up face twice, the front face twice, both right faces clockwise, the front face twice, both left faces counterclockwise, the back face twice, and both right faces twice. And as you'll see, that parity error in which this inner edge group was flipped in comparison with these outer two edge pieces is now corrected, and you can go on to solve the cube like a 3x3. Alright, so this next case is a case that we also see on the 5x5 cube. And as you'll see, these two wing edges or outer edge pieces need to be switched. So, in order to fix this, what we're going to do is we're going to take both of these edge groups and put them on the top face. Now, the way that we want to hold it is we want these two wing edges or outer edge pieces all the way to the right on the top face. Then we're going to perform the following algorithm in order to correct this error. So both left faces counterclockwise, the up face twice, both left faces counterclockwise, the up face twice, the front face twice, both left faces counterclockwise, the front face twice, both right faces clockwise, the up face twice, both right faces counterclockwise, the up face twice, and both left faces twice. And as you'll see, that parity error has now been corrected. The last main case that we see is a case that also occurs on the 5x5 cube, and it is actually not a parity error but can be easily solved with the same algorithm that we used for fixing the inner edge parity on the 6x6 cube. That's also the same algorithm that you used to fix the edge parity on the 4x4. Now the algorithm will look slightly different since we are turning different layers. There is a way that you need to position these edge pieces before you do the algorithm. You want to find the triple edge piece, and you want to find the outer edge piece that needs to go with it. You want to get them to have the same color on the front face. So this has orange on the front, and this last piece has orange on the front also. If they were positioned like this, you couldn't perform that algorithm. So you want them to have the same color on the front face. Once you have them arranged like that, you want this last edge piece to be on the top. So if it was positioned like this, once you got these to have the same color, you just want to flip it over so that this is here in the upper right. Now if you have it in the upper left, you're going to do the algorithm which I'll provide in the video description, which is just the opposite of this algorithm. So the algorithm that you need to correct this case is both down faces clockwise, the right face clockwise, front face counterclockwise, the up face clockwise, the right face counterclockwise, the front face clockwise, and both down faces counterclockwise. And now that case has been corrected. Alright guys, so now that you have all of your centers and your edge pieces matched up, you have basically reduced the 6x6 cube to a 3x3 and can solve it like one. However, since the 6x6 is an even layered cube, we will also see parity errors while solving the cube as a 3x3. My final part 4 will cover how to visualize the cube when solving it as a 3x3, and will also explain how to correct these last parity errors. Thanks for watching.